Hi. Hello. Hi. Hello. And welcome to today's Bombers of Data Science episode, where we are going to talk about how data engineering is done at Netflix. I have been looking into case studies, and I'm working on building a cookbook and focusing on case studies because this is the most interesting point for data engineering. It's okay to understand the tools, but how people are actually doing data engineering or data science platforms, that is super interesting. And some time ago I have been looking into the situation at Netflix, what Netflix is doing. By the way, I have the baby phone here, so if the little one needs some attention, I quickly need to go, but it's fine. Netflix, and let me just get up the screen here. Netflix has some interesting command. Here is it. Netflix has an interesting evolution from the whole platform. If they have switched to in 2016 or end of 2016, they have switched to a newer platform. And how they started with a Chakwa pipeline. I actually don't know Chakwa. I haven't tried this, but the idea here was that is that large enough, or should I zoom in here a bit like this? So they have started with a pipeline, simple event producers. This is more or less the UI that you are using on your browser or your interface or in your app, and that is then sending data to Chakwa, that is sending data into S3. So they are working with Amazon, and then they used Elastic MapReduce to do batch jobs and doing basically batch analysis. And as you can imagine, from the speed, the frequency of getting results with such a solution is not preferable, because it takes some time to get real-time results. This is on Medium. I'm going to put the links from that into my cookbook that you can find on my Patreon, and I'm also going to put them into the description of this video. So what they did, they added a real-time branch. They bolted on something where data is coming in and then gets written into a Kafka stream, and then they use Spark and so on, and a router to then interesting here is the router symbol. I'm going to go into this more in a minute. And they then did some Elasticsearch and again into Kafka. So they basically split it into multiple ways of processing data. This is the first the first thing was the first point of entrance is a Kafka for basically collecting everything, and then they split it. Yeah, that was everything is in the cloud here. This is everything in the cloud. They never started with a local installation, which makes sense if you're thinking about getting into building something big like Netflix. So they said they are 3,500 instances hosting, They have been. This is some old information. This is the first pipeline they used, and then they decided to build a new pipeline, a version 2, that was called Keystone, or is called Keystone. I'm not sure if they have. I'm guessing they have already moved on or built some new stuff onto that platform, but the Keystone platform then was the next thing, and this is a further development. So they cut out the Chakra part, and they moved directly from HTTP, from event producers HTTP calls, I'm guessing, to APIs, and then these APIs post into front-facing Kafka, which are again the collection interfaces or the collectors, and from then you have a routing service that then puts the data into different routes, into S3, into Elasticsearch, into other Kafka consumers, and so on. And so this way, you can basically split the data, and you can build loops. So you and process the data multiple times. You have the front-facing Kafka, which collects all the data. Then you route it into a different Kafka consumer, and then basically what you can do, you can chain this together and write the data multiple times into multiple Kafka consumers, and so on. And so you have a infrastructure that is basically a Lambda architecture, and so you have a batch processing job. Basically, the router writes the data into S3, and then you can analyze it with Elastic MapReduce jobs. My guess is that they already switched away from this, so that here at instead of Elastic MapReduce, they have a Spark instance or something, which makes totally more sense than. This is an old approach. This post is from end of 2016, I think. Let me just check. No, early 2016. So it's a bit older, but it gives you the idea. Question here. So the middle layer is running off an EC2, I suppose. This, I'm not sure what you mean. You mean the control plane layer, or the router layer, or I'm not 100% sure. I'm guessing they have my guess is that the Kafka instances and the routing layer, this is all installed on top of EC2 instances, because where was that? I have another thing here inside the Keystone pipeline. And this is also on Medium, and you can see here. You can see here a number of instances. So fronting Kafka clusters. When was that? That was from April 2016. They had 24 front-facing Kafka clusters. I guess this is called number of instances or something. No, number of instances 3000, and instance type, you can see the D2XL type. So they have with a replication factor of 2. So this is a major installation and a major undertaking. What they are doing here, and is all to get the data in and to manage it. So evolution of. Let me just go back here. Those are two very interesting articles. I suppose you should read them. It's very detailed, and you can also see here in this one they have some design principles, and fail over. Yeah, okay, fail over. This is okay. They basically built this with the replication. Interesting here, they have some visualization with health and so on. And what you can see here, they in the whole article, they never ever mention the tool they are using for this. Oh no, here they say it. They are using Samza as a router, and I never, before that I never heard of Samza. I heard of Spark, Flink, Storm, but Samza is something I wasn't sure about. And the interesting thing here is, so they have, what was that? I'm not sure where that was. So interesting here is also they have all the brokers here. They have Laura. The kids are a bit sick again. So yeah, Samza. This is interesting because this is a tool streaming ETL, event-based applications, real-time analytics. And the interesting thing is always to look at the inputs and outputs, what is possible and what can you do with that. Inputs you can see here, this is you can have Kafka inputs, Kinesis, so this has Kinesis from AWS natively. You can have HDFS file inputs and so on. Interesting also is from the deployment strategy that Samza supports Yarn. And so you can basically install it on a Hadoop cluster. You can use the Yarn from a Hadoop cluster and run it on the nodes of your Hadoop cluster. You can also have a standalone manager. And then outputs, you basically have more or less, you have key value stores, event hubs, HDFS, Elasticsearch, Kafka. So Kafka, HDFS, and key value stores, the main ideas here. And this is very interesting. I wasn't sure how this is used, and how are the contributions to this. Is this still used? And you can see when you look at the contributions on the GitHub, it's quite steady, and they have contributors, and they are doing is that, where was that? Was that paused? No. I'm not sure where this. So it's, if you look into the insights of the Samza, it's also it's a active. No, this was absolutely wrong. It's an active project, so people are developing for it and they are working on it, and as well as on Spark. It's not that popular as Spark, but people are still working on it, and so I guess this is still a valuable addition to all the other systems. Interesting is if you look at if you want to have some input into the differences of the systems. MapR has some links to how are the different systems working, and then they have some where you can see how how the processing of the data is working. And so one thing that is, if you look at the processing model, Samza and Storm, they are focused on one record at a time, where you have Spark micro-batching. And I'm personally not a huge fan of micro-batching, because it's not as clear as with processing one record at a time. And also the latency is because you're doing micro-batching and you're doing seconds batches, it's slower than with something like Storm or Samza. Throughput, I'd say it's good. Another thing here is the processing guarantees. This is also something you have to keep in mind if you're looking at processing strategies. What can you have? At least once delivery, exactly once. Oh man, there were 3. Where was the third one? At least once, exactly, and I've written about this sometime. Yeah. Dragonfly, are you still here? Do you know which one I mean? Sometimes you're... How was that called? This is called at least once, at most once, exactly. At most once, exactly once. And so so the difference is, where was I? They have at least once. So your message is processed, or you can configure it that your message gets processed once or multiple times, or you can process for exactly once, so only one time. And Spark Streaming has only exactly once, where the other ones support more. And the one that is missing here is at most once. So this would then be that you can have processing of a message. Either it doesn't get processed, or it gets processed only once. So when you think about something that what was... Did I have an example? Yeah, some event processing on a user interface or something. So you get an event, and it's not that important to log it. You want to have it, but you don't really need it. But you need to make sure that you don't process it 2, 3, or 4 times. So it's you either you more likely want to drop it than process it multiple times, and they don't have that. I'm not sure why. No one of those has that. Stateful operations, okay. Language support. Just. Okay. Then this is actually what you can do. Okay. You can do counting, like aggregations with Samza. Okay. Yeah. Okay. This is not so super important. What have I prepared here as well? Yeah, this is the, I guess this is the documentation. They have the documentation online where you can look at fault tolerance and so on. So everything. Yeah, I find this. I'm a Spark guy, so I'm more familiar with Spark, and mostly what I am doing is I'm not even doing so much batch processing. I'm mostly working with Spark streaming. And yeah, cool. In theory, it's cool, but when you're doing long-running jobs, stream processing jobs with Spark and Kafka, then you're running into some funny problems that are nowhere documented, and you need to struggle through sometimes and do some optimizations and but it's a Spark itself is cool. It's for what I like is that it comes with something like a Cloudera distribution where you can add it as a parcel and then you have it on your cluster, and you don't need to work on managing it outside of your Hadoop cluster. So one thing that was interesting here as well is this is an addition for today. Just check something. Okay. What they have, if we come, do we want to come back to Kafka? Let's head deeper here. One thing that is interesting here is they have here a special, the specials, and with Samza you can see here Kappa native, and I was wondering what the heck is Kappa, and there is something that is called the Kappa architecture. Let's just get up the link. I forgot to pull up the link. Was that really? Whoops. The Lambda architecture, basically what you do is you have for instance, your Kafka cluster input, then you have your stream processing, and that goes into a speed table, a streaming table with quicker results. And with the Lambda architecture, what you also have is, for instance, you have a Hadoop HDFS, and you're doing batch processing job, and that goes into a batch table. And your app then queries from those tables. So the speed table that is coming through Storm here, that has very quick results, and the batch table that has slow results. So the results are not coming in as often, but you can have results on more of the data, because with Storm you're processing each of the messages from the Kafka cluster, and with the Hadoop processing job, you can store, for instance, the data in HDFS and then process it as a whole, like 100,000, 200,000 of messages, and then put the batch analysis back into that table. And the thing is, what they have come up with, where is it? An alternative, and they thought of something like the Kappa architecture, which is completely streaming based. So you're running the jobs and you output them into tables, and you only have streaming tables. And this is what they also said is there is in another, where is that other video? Kappa architecture, interesting video here to make it a bit clearer. Do I have here the link? This video here is very interesting. Where is that from? Who was that? Where they describe the Kappa architecture, and the idea here with the Kappa architecture is that you move completely away from REST calls or from calls to tables and so on, that you're moving more or less to a complete streaming architecture. So your app or your software, your user interface that is running on web servers, that is connected not only to serving DBs, but onto a streaming thing like a Kafka cluster, and then you can basically stream out the data as it comes in, and you don't need any more batch jobs, because the tables here are it's a bit complicated. I have to say I haven't used this myself. So basically, is with every job with every streaming job you're putting this into a table, and if you're doing a new version, you're putting it into a different table. And I'm not sure anymore now that I'm talking about it. How was that? I don't want to play the video, and in the video he explained it, but I have to say I'm not sure about all the licensing here in on YouTube. I've read a lot of stuff where streams got taken down, so I don't want to play it. But this is a interesting document, interesting video here, where he explains it in detail, how they are doing it. So you are not keeping 2 copies of the data. The idea, as far as I understood it, no, you're not keeping 2 copies of the data, but you're basically able to recalculate the data. What is it saying? So how can I reprocessing? This is some about reprocessing. So what they're doing, use Kafka or simple other system that will let you retain the full log of data you want to be able to reprocess. Allows multiple subscribers. For example, if you want to reprocess up to 30 days of data, set the retention of 30 days. Okay, this yeah, of course. When you want to do the reprocessing, start a second instance, stream, put up job processing data directly, output the data to a new output table. Yeah. When the second job has caught up, switch the application to read from the new table. So this is the okay. So you basically have these output tables. They are not kept both. You run your job version 1, and that job is creating outputs and putting them into the serving layer. And then you can have another version of the job, and you start that. And if you have a 30-day retention time, you get your basically a 30-day batch job. You can create a 30-day batch job and run this into the serving DB then for table n+1. So you don't only make another streaming process, or you let me think. You could basically do both. You can have stop the version, delete the output table. Yeah, no, this is not for batch processing. So as you can see, I'm working through this myself here. Yeah, the idea is you have one version of the job that creates some output, and if you're, let's say you have in this you have some machine learning model that you're applying, and if you're doing some updates on the model in the background, you can have a version 2 of the job with a new model that you're applying, so the output is different. And then you can have, if you have the cluster 30 days retention, you can have 30 days and reprocess it and put it into the front end with basically new outputs. Yeah. Processing changes. Unlike the Lambda architecture, in this approach, you only do reprocessing when your processing code changes and you actually need to recompute the results. And of course, the job doing the recomputation is just an improved version of the same code, running the same framework, taking the same input data. Yeah, that's true. Surely you want to bump up the parallelism on your reprocessing job so it completes very quickly. Yeah, that's true. So Kappa architecture. This is I only have heard before the Lambda architecture, because this is more or less what you use on everyday projects, on everyday clusters. Yeah, but this is something interesting. And I have something more. Let me just check my notes here. No, I think this is it for Spark versus Samza details here. Let me just put this up. Okay, this was okay. This we've been there already, haven't we? Yeah. Yeah, this was not only the documentation. This was a comparison. Okay. Yeah. Some questions. Do you have some questions? Good thing is there are not so many people here, so I have some time to focus on questions. Until one arrives, I'm going to check something here. Okay. Yeah, what is Netflix doing with all this? Do you have an idea for the event producers what this might be? Because this is very interesting. I wasn't sure. Somewhere I maybe it was in one of those slides here. No, just check the slides. What they are doing is it's interesting that Netflix, basically, if you're using the Netflix UI, they are logging everything. So every click you are doing on a symbol, on a film, they are logging this and they are sending it into the pipeline. If you're watching something and you press pause, this is going to be recorded. If you're moving forward, if you're scrolling in the video, if you go back 10 seconds or forward, how often are you starting something? And basically, what you could see if someone is falling asleep. So if someone is falling asleep often during a film, during a movie, he's going to watch, and then he's going to fall back to some point later on. Then he's going to keep watching, and then he's going to fall back, and so on and so on. So he's going to basically get this. You can get the idea of what is happening, and this is all used with something like this. You're putting the information into a Kafka. How are these logs collected? Microservices. These are what you're doing, or what I guess they are doing. They are running APIs. They're running. I guess they are running some REST APIs in front of this here, and they have. I guess this is why they call it what they call a HTTP proxy, and the REST API is then connected to Kafka, and it posts directly into Kafka, and it's a fairly simple thing. It's more or less a microservice because all the APIs are separated, and so you can make updates to the APIs very easily and very, very quickly. And and with the what you can have also with the custom apps here, then in the background, you can, for instance, go connect like again a API to the Kafka as a consumer, to the consumer Kafka, and then stream data out. Or you can I guess this would be then one of the main another streaming use case. Okay. So we've been talking about Netflix, what they're doing. For instance, they are another thing is they are doing the trending now feature with this. So they know exactly what people are watching, and they feed the data in. They put it through Samza or another router, what they are using, I don't know. They put it into S3, and then they analyze it over a day or over an hour, and then boom, you have the most watched things on Netflix, and you can recommend this to people. And then if you connect this information to the preferences of the person, what the person is watching, then you can make a even more recommended videos. You have one of the best channels on YouTube about data engineering. This channel is going to blow up soon. Please keep it. Yeah. I'm not sure about this because this is very, very niche project here, and data engineering is not even remotely that hyped, that important, not important, that hyped as data science. By the way, I just realized I forgot to put up the picture again. So I was pointing at the picture here, and damn it, sorry. The data engineering it's that's why I called it plumbers of data science, because it's not sexy. You can't make some cool deep learning analytics and make some interesting visualizations. It's the basics of the processing. It's basically in the dark. But thanks. Perhaps with more practicals, that will help a lot. I'm not 100% sure what you mean with that, practicals. Something like how do you process with Spark or something. I'm not sure what you mean with that. Yeah. Otherwise, I'm just doing this for fun because again, I think it doesn't make sense for me to go on here and explain how Hadoop works and how Kafka works and how Spark works and how to write simple Spark jobs, because if you're honest, you can go on the internet and you can Google it, and because everything is open source, within a few minutes you can have all the information that I can give you, and even more condensed, even quicker to access. You can even make copy paste stuff. So I think we should look into more into the case studies. I have a lot of case studies in mind. I can show you what I have collected so far. The fundamentals of ingest, processing, consumption, storage. This is the thing is, you very, very quickly get again into the whole into the focus of the tools. It's very, very dangerous that you only focus on the tools and don't understand how everything fits together. And because there are so many tools out there, and you cannot learn everything. And I would say it makes sense to look into Spark or something, but it's super important to figure out how is this used in the real world, because people are asking me. LinkedIn is my biggest network. They are asking me all the time, Andreas, what do I need to learn to become a data engineer? What is it? There is no simple answer. Learn this, learn this, learn this, learn this, and then if you have these tools down, you're going to be an awesome data engineer. This doesn't really work. You can focus on something like Spark, then go into Spark and then figure out how Spark works, but this will take so much time. My guess would be get familiar with one or two tools and figure out how this stuff is working together and what people are doing. So I have let me just quickly pull up the cookbook. Where is it? Here. I need to look past the microphone. Now I need to switch the scenes. Okay. I did it. So what I have done is in the meantime is I have collected some links for all the case studies, and I have been looking into what are companies, what are interesting companies. So I have been, doesn't matter. So I have been looking into Airbnb, Baidu, BlackRock is also interesting, financing stuff, BMW, Booking.com, CERN, Disney, Drive, Dropbox, eBay, Expedia, Facebook, Grammarly, Instagram, LinkedIn. LinkedIn is also very interesting, Lyft, and so on. And what I'm doing is I'm putting all the links for the stuff I'm researching. I'm putting this into the cookbook, and then what I'm also doing, like you can see this with Netflix. I have already put in, because when I researched Netflix, this is some time ago. So the idea is to get to basically create an information of how this all works, how this works together, and then put in the links to everything like I've shown you today. So if we look at PayPal, so the first thing would be, this is only for now, then we are going to for me, this is the basis that I have been looking into. Then I'm going to go into PayPal engineering, and then we are going to look at the stuff that they have been doing here. and compare it to other things we have seen, and so we get an idea basically how all this works out. And my guess is that we are going to see some patterns emerge where people are using a lot of the same stuff, and then you can basically because what I think is that the different niches, like Spotify, that would be interesting to have some other things as well, something like iTunes or something, or yeah. So then you can look into the differences: Pinterest, Instagram, and LinkedIn. So you have this niche, and you can look into what is happening in this niche, or Airbnb, Booking.com, Expedia. Then you have this, and so the more and more we are working through this, and this is only the beginning. Those were the ones that came to my mind, and I have started to research. You can build this, and I think this will be very nice. Yeah. Okay. Something more. This is everything I have prepared for today. Questions? Any more questions? It's 11:21 p.m. So, okay. Yeah, you're welcome, Dragonfly. This is fun. I'm not sure. Yeah. I'm planning to do this every day now. I have said this many times, that I want to do this every day. But as you know how it is. Then you have some other things to do, or you get sick, and so yeah. But the idea is. The idea is we do this stream every day. I'm preparing some use case. We look into it. We talk about it, and then we can discuss some things about data engineering. Hopefully, as you said, people are going to turn up, and you have discussions in the chat, because data engineering is absolutely underestimated. Okay, if you like this one, hit the like button. And if you haven't subscribed already, then that's your fault. And otherwise, we see each other tomorrow. I'm not sure what I'm going to going to look into tomorrow. Maybe we look at Airbnb. Airbnb has a lot of information online about their platforms. We'll see. Okay, then I'll let you know. Bye and see you. Now I need to find the stop streaming button.